Hello everyone. Let's begin with a very simple yet powerful question. What are elements? Imagine breaking down gold, iron, or oxygen into smaller and smaller pieces. At some point, you'll reach the smallest particle that cannot be divided further by chemical methods. That, my friends, is an element. An element is the most basic unit of matter, made up of just one kind of atom. For example, every atom in an iron nail is an iron atom and nothing else. Unlike compounds, which are formed when two or more kinds of atoms combine, like H2O for water, elements are pure in identity. Today, scientists have discovered about 118 elements, and each one is unique in structure and behavior. So, whenever you think of an element, picture it as nature's building block, the simplest form from which everything else is made. Now, here's a thought: if there are only a handful of elements, we could study each one separately. But what happens when you have over 100? That's like trying to memorize 100 random phone numbers. The task becomes overwhelming. To make sense of this variety, scientists realized they needed a system, a classification. By grouping together elements that show maximum resemblance in properties and separating those with large differences, they could create order out of chaos. Classification allowed chemists to see hidden patterns, like similarities in reactivity or bonding behavior, and it made predictions possible. Without classification, chemistry would be like a library without shelves, just a heap of books with no way to find what you need. Of course, this idea of classification didn't appear overnight. Early chemists, curious and determined, tried grouping elements based on whatever similarities they could observe, properties like metallic nature, chemical character, or even the number of bonds they formed, known as valency. Their methods were far from perfect, but they laid the foundation stone. They noticed, for example, that certain elements behaved alike when reacting with acids or forming compounds. These simple observations gave rise to the first crude attempts at organizing elements. Think of it like the early versions of a map, rough sketches, but enough to guide explorers further. One of the most interesting early attempts came from a German chemist named Johann Dobryna in 1815. He grouped elements into sets of three called triads. He noticed that when you arrange elements by increasing atomic mass, the middle element's mass is roughly the average of the first and the third. Let's take the triad of alkali metals: lithium with an atomic mass of 7, sodium with 23, and potassium with 39. If you average lithium and potassium, 7 plus 39 divided by 2 equals 23, which is exactly sodium's atomic mass. Isn't that neat? Dobryna's triads highlighted a real connection between elements, but the method had a limitation. It could not cover all known elements, especially as more were discovered. Still, it was a crucial step forward, like the first draft of a periodic calendar. Chemistry's journey didn't stop with triads. In 1864, John Newland introduced what he called the law of octaves. He arranged elements in order of increasing atomic mass and noticed that every eighth element repeated properties of the first, just like musical notes repeat after 7. Imagine hydrogen as do, lithium as re, and so on, and by the eighth step, the cycle restarts. However, Newland's octaves soon broke down as heavier elements didn't follow the same pattern. Then came Dmitri Mendeleev in 1869. His brilliance lay in arranging elements by atomic mass in a tabular form, the very first periodic table. What's more, he left intentional gaps, predicting the existence of undiscovered elements like gallium and germanium, and his predictions turned out to be spot on. Finally, in 1912, Henry Moseley made a game changing discovery. He showed that the true basis of classification was not atomic mass but atomic number, which is the number of protons in the nucleus. Moseley's periodic law states that the properties of elements are periodic functions of their atomic number, and that principle is the backbone of our modern periodic table today. So let's quickly bring it all together. Elements are pure substances with only one type of atom, and with more than 100 of them discovered, classification became absolutely necessary. Early attempts, from Dobryna's triads to Newland's octaves, paved the way for more scientific approaches. Mendeleev's periodic table gave chemistry its first real structure, and Moseley refined it with atomic number as the guiding principle. Today, the periodic table organizes 118 elements beautifully, revealing trends in atomic structure, reactivity, and bonding. Always remember, it's not atomic mass but atomic number that defines an element's place. I hope this session has shown you how classification is not just about memorization but about discovering the hidden order of nature. Chemistry is full of such stories, and we'll keep unfolding them together. See you in the next session with more fascinating insights into the periodic world.